Hello, Explorer. It's time for you and me to leave planet Earth for just a little bit, and we'll see what science secrets are lurking through the solar system and beyond, shall we? It's a brand new Fun Kids Science Weekly. My name is Dan. This is where we do all the exploring every single week. Thank you so much for listening to our podcast. Well, this week, we really are travelling some distance. We're jumping into a black hole to experience the mind-bending science of what might happen if you fell in.
Once I go inside the black hole, I'll eventually cross this point called the event horizon. And the event horizon is what defines the size of a black hole. It's the point beyond which nothing is able to escape the black hole. Nothing, no matter how fast it is, not even the fastest thing in the universe can escape.
Also, you can hear about one of the most fearless mammals on Earth, and we'll take a look at how robots and computers might change the jobs of the future.
It can't replace humans. It doesn't replace humans. We're still the ones making the decisions. But the way I see it is it's a really powerful robot assistant. Maybe see it as a really powerful tool that we can use to be even better at our jobs.
It's all on the way in a brand new Fun Kids Science Weekly. Let's start with your science in the news. China's youngest ever astronaut has travelled into space. Wu Fei was part of a 3-person crew who blasted off from the Jiuquan Satellite Launch Center, heading to the Tiangong space station. Now, Wu Fei, youngest astronaut from China, is 32 years old. Maybe you thought it would be 5. No, 32, which is still a proper smart adult. The team will spend 6 months on the space station, taking over from another group of astronauts up there, doing loads of experiments, trial and error of what might work in space. Best of luck. Also, a teenager has designed and built a fully working robot hand out of Lego. Jared Lapores from Bristol in the UK spent about 2 years on the creation, helped by his father Nathan, who's a professor in robotics at the University of Bristol. Yeah, that'll go some way, won't it? The hand, which is driven by 2 motors using tendons, has 4 fingers, each functioning with 3 joints. It uses Lego clutch gears. The mechanics of the fingers, they move together until they touch an object, then they stop moving, similar to a human hand. Now, after building this and writing a paper together all about it, Jared was invited to give a speech at a robotics conference in China and was the youngest speaker there. Wow! Loads of young things happening in China this week. How awesome is that? Making a fully working robot hand out of Lego just shows you what you can do with a little inspiration and trying really hard. Brilliant work, Jared. Our final story this week, a new study has found shouting at seagulls may make them leave your food alone. I feel like when a seagull is trying to steal a chip, maybe you shout a lot, and does it do anything? Should we find out yes or no? We're with Neeltje Boogert from the Centre for Ecology and Conservation. Neeltje, thank you for joining us. Now, what made experts decide to research this strange seagully problem?
Well, I live in a coastal town in Cornwall, in the very southwest of England, and we have lots of instances of gulls stealing ice creams and pasties, especially in summer when everyone's hanging out on the beach. And we want to find ways to stop them from doing that don't involve any kind of violence or injuring of the gulls.
So, you want to find a way that they stop going after your food. So here's the deal, Neeltje. My nan really isn't a fan of a seagull. She lives in a coastal town in Wales, and she's really not a fan because she thinks that tourists, they kind of flaunt their chips to the seagulls. And I guess the question is, what are they meant to do? They've grown up to live on that as a food resource, right?
Well, exactly. And actually, it becomes harder and harder to find fish in the sea. We have taken a lot of fish out of the sea. And so if we're just walking around with our food freely available, then the gulls are going to go for that. So yes, the first thing to do is probably to try and keep that food closer to yourself. And also, if you can eat with your back against the wall or under an umbrella or parasol or a roof, then it's much harder for the gulls to fly in and snap your food away.
You're smart scientists, which means you do this properly. You do studies. What did you do? Just get some dude to shout at seagulls? How did you do this experiment?
Well, actually, we got 5 dudes to record themselves on their phones. And so we asked them to say the same sentence, first in a very calm way. So that was, no, stay away. That's my food. That's my pasty. And then in saying the same words, but shouting them. But we wanted to make sure that the gulls weren't just scared of the shouting voice because it was louder. So we got some French fries in a Tupperware container. We put it on the ground. And then as soon as a gull would start pecking at the box, we would use a speaker to play back either the normal speaking voice or the shouting voice. And then we just looked at what the gulls did.
Was there a control, though? Was there anything to test whether the gulls were just responding to sound? Were they responding to any sound? Was there calm noises?
Yes, so we also had a robin, a European robin, just singing a normal song to control for the fact that any kind of sound from a speaker might be frightening in itself. So we expected that the song of a robin wouldn't really affect the gull's behavior at all because it's something they would be used to. And also I forgot to mention, we recorded 5 different men just to make sure that we didn't happen to choose one particular man that was more scary than all other men we could have chosen. So we tried to do the same experiment with a sample of men saying these words.
So you've got the recordings of men saying or shouting instructions for the seagull to go away. Some are hearing robin bird song as well, which is a beautiful sound. What did you discover?
So we found that when the robin song was played, the gulls barely responded at all. Whereas when we played the man speaking or the man shouting, the gulls would all flinch. They would suddenly stop doing what they were doing. They stopped pecking, and in most cases they would leave the area. Now, the essential difference between the shouting and the speaking was that in the speaking treatment, the gulls would just waddle away, whereas in the shouting treatment, they would fly away. So they would really remove themselves from the situation entirely, which is probably a better way to keep them away from your food for longer.
What does this teach us then about when we're going down to the beachfront and we've got chips and we don't want the seagulls to steal our food?
Right. So I actually have a 3-step plan for this. So based on all the research we've done so far, I would advise people to step 1, keep your eye on the gulls. As soon as you turn your back to them, it becomes less scary for them to approach you and steal your food as you're not watching them. So do watch them, and they're less likely to come for your ice cream. Step 2, try to eat with your back against the wall or underneath a roof or umbrella or parasol, just so that you make it much harder for these really big birds with very long wingspan to come and fly in and escape easily again. So if you block that flight path, it makes it harder for them to steal your food. And step 3, if they do approach, if you make yourself big and frightening, approach the gull and shout at them, that should also make them less keen on your food.
I love a 3-step program with this. Now, I guess lastly, just thinking about the gulls for a second, because some people find them annoying, but they are an animal. They are part of our ecosystem. If they're not eating our chips, how do we know that they have other food to eat?
Right. So actually they are omnivorous, which means they eat basically anything they can get their beaks on. So they really like beetles and worms. They like fish. They eat other birds' eggs, also small reptiles or mammals. And so there's plenty of other food that going around. And actually human food is really bad for them. And also most people don't know they're actually on the red list of species of highest conservation concern. So they're not doing all that well. And eating human food is not going to make them very healthy. So we really prefer that people do not feed them at all and instead let them forage for worms or for fish in the sea.
Well, this is a brilliant win-win-win then, isn't it? Because we get to keep our food, the seagulls get to eat, well, and we don't eat any beetles, so there's plenty of them.
Yeah.
The seagulls get to eat the food that is actually good for them and can boost their numbers. What a brilliant bit of science. That's what it's made for, I think. Neeltje Boogert, thank you for joining us.
Thank you very much, Dan, for having me.
Let's get to your questions then. If you ever have anything sciencey that you want answered on this show, anything at all, let me do the digging for you. Let me become a science superhero. I'll do all the searching, sniffing around for the equations, the smart stuff to help you out. Send it. Best way is a voice note on the free Fun Kids app. You can do that at funkidslive.com too. First up, let's get one. It's a review on Apple Podcasts. Thank you so much to someone who says they're Ed Sheeran. I'm not sure I believe them. Ed Sheeran is very, very busy. But if he's got time, when he's flying all over the world doing the shows to listen to the podcast, that's pretty awesome. But still, don't think it's Ed Sheeran. Anyway, question. What's the softest metal that exists? Well, the softest metal is something called cesium. Symbol CS. Atomic number 55. Discovered by some German scientists in 1860. And it's very soft because the atoms are loosely arranged. They're quite spread out from the nucleus in the middle to the furthest atoms that orbit that nucleus on the outside. That's what we call weak bonding. And because the atoms are sliding past each other inside it really easily, it makes it really soft. And it's a liquid just above room temperature. So if you hold it, you are very warm. This metal, cesium, will melt in your hand. It still is a metal, hard to get your head around it. We know that because its atoms conduct electricity. Cesium is used in drilling, finding oil and gas deep down under the earth, also mainly in atomic clocks. This is really important. They're the most precise clocks around. They're used in science and communications, in GPS navigation, seeing where you are on the planet. And that's because the atoms vibrate at an extremely precise frequency. And that lets scientists be able to work out the exact time to the millisecond. So thank you very much for that question. The softest metal, still a metal, it melts in your hand. It's called cesium. Thank you. Let's get on another one. Brilliant. This is a voice note. It's sent in from Jessie. What do you have?
What happens if you go in a black hole?
Well, Jessie, thank you so much for your question. What happens if you go into a black hole? I don't think it can be very good. Should we find out exactly what's going on? Joe Williams joins us from Exeter University. Joe, thank you for being there. So Jessie's asking, what happens if you go into a black hole? I don't think anything good comes of it. What's going on?
Yeah, you're right. It's not going to be a good time for anybody going in. And there's one real fun process, which is a really fun name that I'll come to, that happens when you're going into a black hole. So let's say, for example, you and I are standing outside a black hole, watching it from far away. And then I decide foolishly, perhaps, to go inside the black hole. What you'll see is you'll see me go towards the black hole and then start to slow down. And then at some point, I will suddenly stop moving and then I will fade away. I won't look like I've actually gone into the black hole. The light that's being bounced off my body ceases to exist. It starts to become more red as it becomes more stretched out by the extreme gravity around this black hole. And then I will simply fade out of existence. From my perspective, however, I will see the rest of the universe speed up. It looks as though time everywhere else is going really, really quickly, whilst time for me is going really, really slowly. So a watch on my wrist would be ticking at a normal rate for me. But if I looked at a watch on your wrist very far away from the black hole, it would be ticking really, really fast. And then, once I go inside the black hole, I'll eventually cross this point called the event horizon. And the event horizon is what defines the size of a black hole. It's the point beyond which nothing is able to escape the black hole. Nothing, no matter how fast it is, not even the fastest thing in the universe, light, can escape from the black hole. And this is why they're black. No light can escape from it, so we can't actually see it. And all those pictures of black holes that you may have seen, the circle that defines the edge of the black circle, that's the event horizon. And once I go inside of it, the gravity in the black hole will pull on my legs, and it will pull on my waist, it will pull on my chest, it will pull on my head. But because my feet are closer to the center of the black hole than my head, it's going to pull more on the feet rather than my head. As a result of that, I'll get stretched out in a process that we call spaghettification. That's right, spaghettification. So you turn into pretty much spaghetti of some kind, and then all your material is dragged down to the black hole. And I think it's pretty safe to say that anyone that would go into a black hole is not going to come back out and won't end up in one piece.
There's some thoughts, myths, I would imagine, that these might be wormholes. So is there any chance, Joe, that if you managed to get into a black hole, you could find yourself thrown out millions and billions of light years across the universe?
Yeah, it's a great idea, and I really like these kinds of ideas. Unfortunately, our current models of mathematics and physics aren't capable of describing what goes on inside a black hole very accurately, so we can only really conjecture based on our current understanding of the universe. Any black hole that exists could possibly become some kind of wormhole. We don't quite know. So if you went inside one, you might pop out somewhere else in the universe. But similarly, I've come across a theory a long time ago when I was doing some reading around, which said that if you go inside of a black hole, because time goes very slowly for an observer like me going into the black hole compared to you who stayed outside of it, the universe just ticks on by. And what happens is the black hole may actually be some kind of collapse in slow motion. So you'll go into the black hole, and then as the universe ages outside of it, suddenly you'll bounce back out, kind of like a big supernova almost. But black holes bounce back potentially in a really, really, really slow way, and they take a very long time to do it. And it takes so long that we've never seen something like this. However, this is just a theory, and we don't really know if this is the case. But I think it's quite fun to think about.
So I chat to so many people doing this, and I've learned so much about science. But that idea of time going slowly for me, but really fast for you, is one of the most fundamental concepts in science, all about relativity. But I still struggle to get my head around it, Joe. Now, we know that black holes, they are made from just this immense force of gravity, as you've mentioned. How do we know how close you might need to stand, if that were possible, near a black hole before you'd start feeling that gravity tug away at you?
Yeah, it's a great question. So there's a small technicality we'll start with, because I'm a physicist. I have to start with these technicalities. Everywhere you are in the universe, no matter where you are, you actually feel the gravity of these black holes right now. But it is so small compared to the gravity of the Earth that you just don't even notice it. But every single object in the universe that has some kind of material to it, like you, me, my headphones, this cup of coffee that I'm drinking from, everything has material, and everything has a gravitational pull on everything else around it. So that's the technicality. But like I said, we can't really feel it from so far away, especially my coffee cup. I can't feel the gravitational pull of that because it's so small. We would have to get reasonably close to the black hole to really start noticing it. If you end up within probably certainly a few thousands, definitely, but perhaps a few million kilometers, miles, 10 million or so within the black hole, then you'll really start to feel the gravitational pull.
I love the idea that that's quite an insignificant amount of distance when you're in space. What a joy to discover the answer to your question, Jessie. Thank you for sending it in. And Joe Williams from the University of Exeter, thank you for joining us.
Thanks very much for having me.
If you ever have a question that you'd love answered, just like Jessie, make sure you leave it as a voice note for me on the free Fun Kids app and at funkidslive.com. It's time for this week's Dangerous Dan, where we search out the most weird, unique, strange, and deadly things around. This week we're headed to the wilds to meet one of the most fearless mammals on planet Earth. Not fearsome, fearless. Because it goes for it. It doesn't matter who it takes on, it battles. And actually, that makes it quite fearsome. Across Africa, India, and the Middle East, you might find the honey badger. It's about the size of a dog, which is surprisingly small for such a strange beast. It's got a black body with a thick white back that stretches down to its eyes. It actually looks a bit like a helmet, and that's pretty appropriate because the skin is tough. It's a bit like armour. It bites, scratches, even arrows don't get through it. What's remarkable, if the honey badger is grabbed by a predator, it twists inside its own skin. It can bite back. Not only that, it's pretty determined to stay alive. It can survive bites and venom from cobras and adders and rattlesnakes, even scorpions. If it gets knocked out by venom, it just wakes up a few hours later and gets on with its life. It keeps fighting if it can, and it's incredibly smart, using rocks and sticks to break free from a cage. And they're aggressive. It attacks with razor-sharp claws, bone-crushing jaws. It's ferocious and it's fearless, right? When they're cornered, they all charge, they all bite, they all fight to the death. And because they're immune to loads of venom, that means they eat toxic creatures that would kill many other animals, which gives them plenty more food. So they're kind of thriving. They're fearsome and they're fearless. And they're an amazingly strange beast, which means the honey badger goes straight onto our dangerous Dan list. It's time for this week's Battle of the Sciences, where we try to discover, once and for all, what's the greatest science of them all. What's best? What's the best field? What's the greatest of the whole lot? This week, something a little bit different. We're looking at numbers. We're looking at figures, how that shapes our understanding of data and the future. We're talking economics in science with Alex Dryden from SOAS, University of London. Alex, thank you for being there. You have 1 minute to tell us why economics in science is the best of them all. That minute starts in 3, 2, 1, go.
Thank you very much for having me on. Look, economics in numbers, it's about understanding the world around you. Economics really is very, very powerful for helping us understand what's happening, understanding the patterns, the changes that we're seeing in the real world, and in some really extreme forms, being able to shape it. In that regard, it's a little bit like a superpower. You understand the numbers, you understand the shapes and the patterns, you can start to shape the world around you. Now, one of the things that we've seen changing both the science world and the economics world is the establishment of AI. And this is a buzzword that people are using a lot at the moment, but AI stands for artificial intelligence. And one of the things that I like to use to explain it to people is it's a little bit like a sort of really super fast helper in terms of helping you spot patterns and kind of like a detective for the numbers, if that makes some sense. So we can use it to study things like money, prices, jobs, all of the things that help people make choices in the world. AI can really help us do that by zooming through the mountains of information that we have way quicker than I could as a person, and helping me as an economist make sense of that faster.
Well, Alex, there's your minute. Thank you so much. We hear loads about AI on the show, and I think we're really intrigued as to how it works and the technology and the science behind it. Perhaps at times we're a little wary of where this might take us in the future. But you say that when it's kind of helping you sift through the data. So how are these scientific computers helping you do that? Like, what data are you looking at? What do the numbers say? How is it being streamlined?
So, great question. So how does AI work? So really, AI learns from examples. So what we do is we show it lots of data about how people, for example, spend money. And it learns to spot when it sees something unusual. It starts to see where the trends are. And if you give it information about, say, prices that we see in the economy, like the price of eggs or the price of milk, it can guess what might happen next. So it's a little bit like being able to predict when something might get more expensive or when it might get cheaper, because everybody suddenly wants to buy them. AI can help us digest that, and it allows us as economists and in the science realm as well, to use it as a really powerful tool.
Is there a worry that AI might become so good that it cuts out the middleman of you, that it's just brilliant at looking through this data and it can interpret it and figure out how it applies that to the future on its own?
Yeah, I think there's this real worry that AI can replace humans. It can't replace humans. It doesn't replace humans. We're still the ones making the decisions. But the way I see it is it's a really powerful robot assistant. Maybe see it as a really powerful tool that we can use to be even better at our jobs, even more efficient, being able to come up with even better and more amazing ideas. But we're the ones that are directing and controlling AI. We're the ones that use it as a powerful tool. It doesn't end up replacing us. We've seen technologies come and go for hundreds, if not thousands of years, and they always help us do a better job rather than replacing humans.
One of the things that I love doing, chatting to experts just like you, is finding out how you've got here and what really excites you about your work, just in case someone is listening and is brilliant with numbers and things. I might do economics and the science side of things. So when did you first realise at school that kind of numbers were your thing?
I realised when I was about 12 or 13 that numbers were my thing, and I really enjoyed taking those numbers that I learned in, say, maths or some of the sciences, and applying it to the real world and seeing how that shaped both like geography and economics and history. Those sort of subjects really intertwined. And I really like it. Economics sort of sits there between the subjects like history and geography that people may do as they move into secondary school. And it really fits nicely with the sciences and with the numbers. And so if you like both camps, then maybe economics is for you.
And just let me throw you into the future, Alex. Years and years and years towards the end of your career with numbers and economics, I always ask this question. What's the one thing that you want to know? What do you want to discover? How do you want your field to change and get better?
I think one of the things that we're struggling with a little bit at the moment with economics, and we've struggled with this for a while, is that economics as a field is typically being done by men, and typically white men. One of the things I would really, really like to encourage people to do is to see more women come into economics, more girls embrace economics and really enjoy the maths and the that can come from it, and embrace that as well. Economics needs to have a diverse set of people working in it because it matters to the real world and it shapes the real world. So it's important that more and more people come into economics from different fields and from different backgrounds. So anyone listening, if you really do, especially if you come from a different background or that you're a girl interested in maths and interested in sciences, please look at economics as well, because I'd really like to leave it in a more diverse place than when I came into it.
So, economics, how do you think it does? Is it the world's greatest science? Are you all about numbers and facts and figures? Alex Dryden, thank you so much for joining us.
Thank you.
Thank you so much to Alex for coming on, helping us understand AI and economics, just teasing the edge of sciences. But I think it's really worth hearing about all the different careers and the different work that people do still within the world of science. So thank you so much to Alex for coming on. Now, earlier on, we had a question, didn't we, all about heading into black holes. Jessie, thank you very much for that. Well, we can stay in space right now. We're jumping through a wormhole to Deep Space High, the smartest school in the solar system. And we're joining Mrs. Higgs and her class as they're checking out their projects that they've made for the Galaxy Gala. There's just one thing missing, a black hole.
Deep Space High, the Galaxy Gala with the Royal Astronomical Society, advancing astronomy. Jumping through a wormhole and travel to Deep Space High, the school in space. But hurry, because lessons are about
to begin. Well, you should all be very proud of your efforts, class. Our galaxy for the gala is very nearly complete, and it looks simply spectacular. Just look at it. The star systems are secured, planets populated, and nebulas, well, the nebulas are nice and fluffy, all in a beautiful double spiral. Well done. But to really make our entry a showstopper, I'd like us to include one more thing, class.
A lovely set of curtains?
No, Quark. A black hole.
But miss, aren't they incredibly and unbelievably dangerous?
And incredibly and unbelievably fascinating, Quark. They're one of the strangest things in the universe. We're going to get as close as we can get to a real black hole, so I want everyone to buckle up and stay in their seats. That means you too, Quark.
Aw, just looking for my space beetles, miss. They've escaped again.
No time for space beetles. It's time to go. We're going to get as close as we can to Sagittarius A. It's a black hole believed to be in the center of the Milky Way. We can't see it because black holes swallow light, making them invisible.
So what's to say there's anything there at all?
Well, scientists get clues from the behavior of stars and other matter nearby. When a really enormous star dies, all of its matter gets sucked inwards until everything inside is a tiny dot. And this dot has so much gravity that it pulls any and everything nearby inside.
I can't see anything. It's just totally black out there.
That helps me to know that we're in the right place. You can see, well, that there isn't anything to see. No planets, no stars, not even one measly piece of space rock. But the computer is showing that something in this expanse of black space is as massive as over 1 million suns.
Freaky. So where's it hiding? There's nothing there. That is seriously spooky. Something so enormously massive, and yet We can't see it at all. I don't think I want to get much closer.
Don't worry, Sam. We're a safe distance from the event horizon. That's the edge of the black hole. In fact, as we're in the super safe space lab, we can just get a little closer. Watch the clocks, everyone.
What's happening, miss?
The laws of physics, including time itself, are getting distorted as the enormous forces pull everything inside. We should back out a bit before it's too late.
That's better. If you were ever unlucky enough to be sucked into a black hole, it's believed that you would be stretched into a long, thin thread in a process called spaghettification, before being crushed into a tiny speck with all the other matter. Yeah! So, you can see it's a very good job that the doors of the space lab are secured.
Quark. Aren't they your space beetles over there on the safety doors? Nibbling at the wires?
Yay! It's Mr. and Mrs. BP! Oh, they love nibbling wires.
Oh no! If those doors open, we could all be sucked into the black hole. Stay buckled in your seats, class.
Oh, it's too late! Hold on tight! Oh, miss! Our Project Galaxy! It's being sucked out of the lab and into the black hole! Oh, it's gone forever! Your bloomin' space beetles nibbled the wires holding the door, and now our entire galaxy has been sucked into a black hole! Every last planet and star!
Oh no. Sorry, everyone.
We'll have to start again, but right now we need to get out of here before it sucks us in too. Let's get back to Deep Space High.
Deep Space High, the Galaxy Gala with the Royal Astronomical Society, advancing astronomy.
Thank you so much to Mrs. Higgs and the team from Deep Space High. You can hear loads more of those brilliant podcasts. And we've got tons more episodes that explore so much about the world of science and different subjects wherever you're listening to this. You can get it on Google, Apple, Spotify. They're on the free Fun Kids app and at funkidslive.com. That's where you need to go as well to send in your voice notes. I'd love to hear you so you could star in the podcast. Any question that you've got, fire them over there. And Fun Kids, we are a children's radio station from the UK. You can listen all across the country on our app, on our website, and if you've got a smart speaker, wake it up and ask it to play Fun Kids.